Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Well, here we are.
Here we are. We've been thrashing about for the last week, trying to get someplace.
Some thrashing.
It's been
a thrashing week.
Yeah, because you've been
in build hell.
In the
pain cave.
In the pain cave, yeah. I've been avoiding the pain cave because sometimes my brain will work things out in the background.
Yeah.
I've got a background process running that's slowly making sense.
Yeah. You have a little bit of CPU allocated to that background thread.
Or maybe a lot. I don't know. It's just I'm unaware of it. I was thinking about that maybe we do have to understand where things are broken in order to come up with a reasonable mental model for them.
Yeah.
And that's what I think both you and I are struggling with. And apparently other people on the internet, because I've gotten periodic messages that say, yep.
There are other people in the same boat struggling with the same thing.
That cannot pretend that they understand what Gradle is doing.
Yeah.
But, anyway, we've complained about that enough far. We don't have any new insights other than possibly got to understand how it's broken before you can understand how to create a new mental model.
Yep.
But, and you said Scala 3 is today?
I think Scala 3 is today. Yeah.
Wow.
Yeah.
They're
having a release party. So
it seemed like, they were considering new features. And I was going, oh, well, we're not going to see Scala 3 for a year if we're still...
Maybe Adrian was like, Martin, you got to stop. No, we cannot put in new language for exception handling. Like made him stop.
Yeah.
Scala 3, I'm excited to switch to it. I think there's a lot of really nice stuff in it. And I think that when combined with other things in the ecosystem like Zio, I think it's going to be pretty amazing way to build code.
What's your favorite Scala 3 feature? Or features?
The thing that has been most evident in our playing with it is having the type system actually based on a calculus gives you some really interesting kind of usability things that I don't have in Scala 2. Remember when there was some place where we got this like type error and it was like, how in the world did it know that? And I guess
we were all kind of stunned by
like,
how this is different.
It was just a super useful compiler.
Yeah.
And I think you can do that when you actually have kind of algebraic laws around the type system.
And that was really the fundamental shift in Dotty, right?
Yeah, was like, Dotty is all about the dot calculus based compiler for the type system. That was one of the core things for Scala 3. And it's been in research at EPFL for, I don't know, 5, maybe more years. Martin's probably been thinking about it for 10 years. So,
well, and it seems like other people would have been doing work on, it's all PhD research kinds of things. And I'm sure that's been going on for decades.
Yeah. Yeah, and I guess performance improvements to the compiler also, like that you can get a lot better compiler performance.
You mean the compiler's faster?
I think it's supposed to be. I don't know if it is yet. I don't know how much benchmarking they've actually done.
But
the dot calculus is supposed to make it so that the compiler can be a lot faster.
And what about code generation? Is that
which code generation?
Well, in other words, the quality of the code that it's generating, is that going to run faster or?
Oh, that's a good question. I don't know. Yeah. Cause it is going now from Scala source to the new AST format, the tasty format, and then to JVM bytecode if you're, doing stuff on the JVM. So can they do more optimizations in that like tasty to JVM stuff, or are they doing more? I don't know. It's a good question.
But I can also see the argument of, well, we're going for reliability and, I can write a program that runs really fast, but it's very unreliable.
Right.
So maybe we need to reverse the priorities and make reliability
more important.
I have to say, this is just a surface thing, but some of the syntax changes, especially the Pythonic removal of the curly braces.
Yeah.
I just like cleaner code.
Yeah.
More straightforward.
When we have been writing code, you and Bill and I, the code is much more concise, much more easy to read. The one caveat to this, and I really wish they would have taken a little bit more time to figure this out, is the inline like functor syntax. You still have to use the braces, and it just feels so.
It stands out.
It stands out.
Yeah, you're going, oh, no braces except here.
Yeah, except here.
Yeah.
I mean, I get that it's a super tricky problem to figure out how to do. How to do away with the braces in that case. But I wish they would have.
Sticks out, yeah.
Because I think what's going to happen is I'm just going to not use inline functions like that anymore because it's just going to look terrible. So what I'm going to do is always define functions outside and then reference them. Just so that I don't have to use the braces. Which maybe that's ultimately better. I guess we'll see as I write more code.
Yeah, that is. So no lambdas at all?
Not if I have to use a brace. I mean, you can still use the underscore syntax without the brace.
Oh, okay.
It's just like when you need like a multi-line.
More complex lambda, yeah.
Yeah. I guess if it's all single line, then I think you can just use normal function syntax. It's really when you want to when your functor goes down to a second line is when you have to put it in braces.
So I think also, wasn't there some cleanup? I mean, like Scala 2 had a lot of, I want to say, exploratory syntax. Well, there's also the dirty little corners, which finally snapped my brain. I don't remember what it was. There was an H involved, and it was just something magic. And I'm going, all this time, this is the first I've seen this. It looks really important.
Yeah.
And I'm okay, screw it.
Yeah.
And, but it was more, I mean, like, aren't there restrictions on what you can do with operator overloading now?
I don't know.
So you don't end up with the ridiculous operators that people were inventing that just make the code incomprehensible.
Yeah.
You know, it was like,
I don't know what they changed around that in particular.
Okay.
One of the interesting things we discovered is that in Scala 3, it uses the Scala 213 standard library and then just makes some tweaks to it. So it's interesting that, like, with this release of Scala 3, it's using the old standard library. So like the collections APIs haven't changed, which also means that they're not taking advantage yet of the Scala 3 features like built-in type classes in the standard library really yet. And so I think in 3.1 is when they're going to rewrite the standard library for Scala 3. And so it'll be interesting to see what happens then. But remember, we were like looking at IntelliJ, and IntelliJ like linked us into the 213 standard library when we like control clicked on something, and we're like, that can't be right. And then we dug in, and it seemed like, no, that actually is right. Like the Scala 3 standard library is the 213 standard library, which I think is a great thing for interoperability between 213 and 3. But.
Well, yeah, we learned this going from Python 2 to Python 3. And it was understandable in that case, but the pain was so much more than I would have guessed with it didn't seem like such a huge change going from 2 to 3. And yet all the libraries had to change.
Yeah.
And so being backward compatible with your existing libraries is, certainly if you can pull it off, that's what you want to do. They couldn't in Python.
Yeah.
But now they can do all kinds of amazing things in Python that they couldn't before, like adding pattern matching.
Right. Yeah. Yeah. So it'll be interesting to see how quickly the community uptakes on Scala 3. I think what usually is the thing that holds people back is libraries, the library ecosystem. So if you're using Spark, you may not be able to move to Scala 3 for a long time.
So you think it can't just recompile Spark in Scala 3, or?
I remember that it took them a lot of effort on the last time they upgraded Scala versions for Spark, and I don't know why, but I'm anticipating that it'll be a while, many years, before we see Spark upgrade to Scala 3, which is unfortunate.
It seems like
Play and Akka will probably upgrade pretty quickly. Zio is, I think, already has RC releases for Scala 3, so I think that'll be the interesting thing, is like how quickly can the library ecosystem upgrade?
Yeah, it is. I mean, it's interesting because my perception is, whereas the Python 2 to 3, there wasn't a huge number of, syntax changes. It was more the underpinnings that had to change and affected everything. Whereas with Scala 3, there's like really significant syntax changes.
Yeah.
And
I wonder, what I haven't done is taken a Scala 2 code base and just try to compile it with Scala 3 and see like how much is kind of backwards compatible from a source compatibility standpoint.
That would be interesting. That's going to happen a lot.
Yeah.
So it'd be a good.
I remember they were working on some tool to make it easier to like auto migrate source code, like auto redo source code. I forget what the name of that one was, but I don't know what the state of that tool is. But it definitely would be nice if you could just get 90% of the way there on your code migration by running a tool.
Yeah, I have to say my feelings. I with Scala 2, I got to a point where there were just too many sharp edges and drop offs and things like that, and I just kind of. Whereas this, I have better feelings about, and of course, part of it might be because we're starting to venture into the Zio territory, and that's like a whole new way of thinking about programming. Like, I mean, it's like
you need a firmware update on your brain.
Well, yeah. I mean, I think we can pull this off. You know, I think we can explain it in a way that makes sense to people. But it's like, well, it's taken me, I mean, we've bashed the idea of monads around for several years, and every time I'm going, okay, so tell me what's a monad. It's a burrito, it's a diaper, it's a...
Yeah. Why is a monad?
Well, which was the question that I should have been asking.
Yeah.
But everybody wants to answer the what question and not the why.
Yeah.
I don't know. I'm still baffled why people don't think about that. But I guess, I don't know. It's just, it's very strange. But anyway, and maybe it's just they made a bunch of changes which appealed to me on an aesthetic level. And also, I've spent 3.5 years writing the Kotlin book, and that has moved me even more into understanding the functional programming world. And so anyway, I have right now good feelings about the possibilities for going back into Scala and not coming away bruised and burned.
Yeah, I think with Scala 3 and Zio, we should be able to have a much better happy path.
For sure. Yeah. Well, in fact, this week we had this, you and Bill and I had this big kind of revelation, which is, hey, maybe this book shouldn't be a dive into all of the extensive features of the language like every other book that I've done in the past has been. And maybe instead we should let that other people do that. And
there already are like 5 other books.
There's 5 other books coming out, and there's, Bill Venner's the kind of flagship book, and he's going to go into all of this. That's going to be the reference work.
Yeah.
And so wouldn't it be interesting if instead we say, and the only book that really came to mind, even though it's not exactly a mapping, but it does make sense, is my friend Scott Meyer's Effective C++. And what an impact that made, because it was saying, okay, the other books are all the features. Here's how you use the language well.
Yeah.
And what if we went there instead of... and I got to say, I've been, this has been in the back of my mind for a while. Just, wow, is this my fate in life to explain all the low level features at some point?
It's you spent your time in penance in
I've done my
seventh realm of hell.
And it's like, the first few times it was interesting enough to try and explain, well, here's bit layouts and shifting and stuff like that. But at some point you're just going, not again.
Yeah.
Not again. And also the value I think we can create by taking people to, here's the most productive and valuable thing you can do with this language, rather than here are all the language features.
Yeah.
So
I'm excited about this shift in our thinking on the book. When we were starting to work on the just language Scala 3 book, Atomic Scala, I kept having this tension in me, which was, okay, we're going to teach them something about the language. And then what I want to say on a lot of those things is, but never do it that way. So there's this tension of do I really want to teach you all these language features when I really think you should not be using a bunch of them?
Right.
It's like println. Don't ever use println. That's an effect. It needs to be in an effect system.
Right.
And so just that's a silly example, but
maybe not.
Certainly I use println for debugging.
Well, right. But in a piece of production code, and even in our examples, do we want to use println?
There won't be a println in our examples.
I mean, no, we'll just,
it's not something that should be in production code.
Yeah. I mean, how we achieve that is going to be interesting, but it's to just start and show people the
happy path.
Yeah, well, which might not be happy for them right away.
Right. Yeah.
If you're coming from a language which is,
why is this so much harder? And it's we are going to eat some of that cost and pain up front so that you are much happier later.
But I think the structure that I put down in the middle of the night a couple of nights ago, because it kept going around in my head, if we present it as, here's what you want to do is create reliable systems.
The why, yeah.
The why. Start with the why.
You want to have something you could put on a Mars rover.
Right. And not worry about
bricking the thing
or having your, what was it? The French missile, the French rocket that blew up. And that was a software problem. Yeah. That was, I don't know, years ago.
Okay.
Many years ago. But you don't want, you don't want people going, it's the software guy's fault.
Yeah.
Person's fault. You don't you don't want that. In any of your systems.
Yeah.
You don't want to be woken up in the middle of the night. You don't want
exactly.
And it's like, you want to build a reliable system. So what is that? And how do you achieve that? And it's a very different way of looking at programming than what we've done before, but the possibilities are. And it's also something I think I'd be excited to go back to teaching about and consulting about and everything. For sure. I think that would be that would have exciting possibilities. Whereas if you tell me, well, you can come in and teach people how to do bit shifts in Scala, I'm going, I don't know.
Not that exciting.
I don't know if I want to.
Hard to motivate.
Yeah. So, and we're going to try and avoid using var. We'll use it if we have to, but
yeah, we have to.
But then we'll have explanations and disclaimers.
Yeah.
About why. Well, because I think we're going to, or at least my current vision is we're going to have a whole section on invariance and the benefits and, how to achieve that. And so,
describe invariance.
Just being able to, it's like a mathematical formula. When you plug in values, you always get the same result.
Oh, and like referential transparency,
immutability, all of that kind of stuff. So
I was thinking we were talking about like type system variance.
Oh, right. Covariance and contravariance. Well, yeah, we might need to use a different term
Yeah.
to make it very clear. Referential transparency is kind of a scary term.
It is. Yeah. I guess that'll be one thing we'll have to figure out is
yes.
like how much do we introduce the scary terms?
Well, I would say as little as possible. I don't want to scare people off. We can, start with something straightforward, and then we can say this is also called referential transparency, or
start with the why.
Yes.
Introduce the thing, talk about it, and then at the end be like, oh, and some people call this referential transparency.
Yeah, so if you encounter that,
we'll do the same thing with monads.
That's what we're talking about.
Some people call this a monad.
Oh, okay. What term will we call it? A box to put things in, or a
burrito. Just call it the burrito trapper.
Or a diaper, or
the diaper trap.
The diaper. Yeah. Or
chainables.
There's you've probably encountered this since you have young children. There's Winnie the Pooh episode where he's got an empty jar, and I think it's Piglet's birthday, and so he gives Piglet this empty jar, and he goes, "It's a pot to put things in." It's like, well, that's what a monad is. Yeah. Oh, you just passed this, but I realized, it's thinking about all the terms, it's a container. Oh wait, it is literally a container.
Apparently, there are monads that are not containers.
Sure. Yes, but the general case is that it's a container.
It's a very special container.
Yeah, and we treat it as a container.
It's can be a container. Can be a container with some special properties.
Yeah.
So this is going to be fun.
It'll be an interesting challenge, but
we'll start with like okay, why are monads important? Why?
After we get my current vision is we start out and we talk about reliability.
Yeah.
And what makes software reliable? And most of the last, couple of decades have been spent on creating a reliable development process with things like
CI/CD and source control,
all this automation to check your code. But then there's the other half, which is the code itself, the structure of the code and the framework and scaffolding and everything being reliable. And that's the part that I think we haven't been focusing on.
Yeah.
And so there's that. And that's what we figure, okay, if you're reading this book, you understand version control, automated build.
You've already got testing. These other reliable things down.
Those are there. That's part of your development process.
Yeah.
And also, I realized versioning, not just version control, but versioning, which, we're not going to try and solve that problem, but
we're going to be focused on the programming model side of reliability.
Exactly.
Not the practice side.
Yeah. Which feels like it's
process
reasonably covered, not that everybody's doing it, but that, that information is out there, but we'll be focusing on the programming model side.
And I think one of the interesting things that makes this reliability challenging, is concurrency. And so it'll be interesting to kind of weave that in as well, because you could imagine a programming model where you were able to have great reliability, but your performance in a multi-user world or multi-core, multi-machine world was just horrible because there was only ever one instance or one thread essentially.
And you're waiting on tons of things out in the world.
Right. Yeah. And so I think that'll be an interesting kind of cross-cutting concern to this is reliability and performance at the same time.
Mm-hmm.
And then there's another kind of cross-cutting thing, which is like software that doesn't talk to the outside world or mutate state is pretty useless. And so then you've got this whole element of okay, how do you make reliability given that you're going to talk to other things
without weaving it through your old code like we always do.
Fail. Yeah.
So we have to isolate those things which I believe we call effects.
That's right.
So we put the effects in boxes, and then we control
containers,
those boxes. Yeah. We control those boxes or pots or whatever, and then the rest of the code can be whatever we're going to call it, invariant or something. It's like never changes. Once you get it debugged, it stays debugged.
Yeah.
You can compose it, which I think is an important
composability. That's another
composability, which I think is a section, because you go, so you can compose code. That's great. But what if one of those things has a problem?
Yeah.
What do you do then?
Yeah. Yep.
Yeah. I mean, it's all starting to fit together in my brain, and there's probably stuff that's wrong, but I feel like we're maybe going down the right path.
Yeah.
And especially having it, each section starting with, what are we trying to do? What problem are we trying to solve here?
Yeah.
And then, adding more of those until we get to composable effects, and then whatever comes in after. Yeah, I'm not sure what Zio layers do. I only saw that one.
That's like the dependency injection piece to it.
Oh, okay.
Yeah.
Well, all right.
Yeah, definitely. We'll get into Z layer and how we can change the environment for tests or for development, production,
okay,
that kind of stuff,
without messing up our programming model that we've been so careful. Yeah. See, the thing is, I think when we get there, it will make sense. And that's of course the goal, is to be able to say, okay, now next step. There's another problem we want to solve, and we spend a section solving that.
Yeah.
Now you understand that, and now we have this.
Yeah. Yeah, and then there's like the data modeling piece, which I'm sure we'll talk a bit about. And I think we talked about that last week on the podcast, about how representing your types as modeled as accurately to the real world as possible.
Right, which seems like it should be obvious, but I guess and I guess the way I've seen it is like, oh yeah, when you have a real world system, you can say, there's a ship and it has a container, and the container has products and stuff, and you can make that. But then there are the internal pieces of your code, like just the piece, the software construction pieces. Yeah. And so there's that. Which part are you doing? Yeah. And then we had a little discussion about, I think we were talking about, I know, I asked you, hey, why is the data, in functional programming, you've got the functions, and then you have the data structure that it operates on. And that's invariant, doesn't change, and then a function acts on it and it creates a new data structure. Why couldn't you do that with objects? Yeah. Just say, okay, anytime I make a change to the object, I hand you back the changed object and the original one stays the same. Yeah. That seems like it would be a nice functional object compromise. And you said that you did that, but then when you started to compose objects,
the nesting.
Yes. Yeah. When you use composition, it becomes
it. So when you nest these like data classes or whatever you want to call them, if they're immutable and you need to change something deep down that hierarchy, then it becomes nasty, because then you have to do this like dot copy and then change the thing and then dot copy, and name parameters in the copy function like help with that. But it just gets pretty ugly. The programming model feels not nice. And so for that particular problem, there's been some work done around what's called lenses. And lenses allow you to define a kind of query of your object graph. And then when you want to mutate down in the nested structure, you say, all right, here's my lens that's going to tell you where to mutate. And then you tell it the new value. And then it does all the nastiness, copy, whatever stuff for you to do that mutation. It's not a mutation, but do the deep copy with the updated value and give you back that most external object. And so it's a lot nicer programming model for dealing with nested data class.
Right. And I had heard the term, and I think I tried to understand it, but again, I didn't know what problem it was trying to solve. Yeah. And so it didn't make sense to me. And you said that these have only been partially successful, or?
They're not widely used.
Okay. Maybe because people don't understand the issue.
The syntax on the one that I've used is it's a little scary because it uses like a lot of operators and like kind of what you want is a query syntax that is more familiar. And so remember LINQ in C#?
LINQ.
Yeah.
Right. C#.
And it's really nice kind of programming model for doing object queries essentially.
Right.
And if you could have a syntax more similar to that would be nice, but
kind of separating the data representation from the object and saying, okay, we're going to do this in a particular way. And then the rest of your object is going to be what you're used to.
So I think that there actually is a lot of potential for making lenses a lot easier in Scala 3 because of the GADT stuff that they are doing, the derived type classes.
Generalized abstract data types? Is that what GADT stands for?
Something like that. It's something abstract.
Okay.
I'm spacing on it, but I don't understand what GADTs are at all. But GADTs are like the mathematical category theory, Haskell, whatever that is the foundation for having the compiler derive things for you. And so serializers are like the serializers and deserializers are the canonical example, but I think that lenses could actually be significantly improved with GADTs and derived type classes, but we'll see. Could be totally wrong about that. I'll have to have somebody that knows what they're talking about tell us more, but it'll be interesting to see how Scala 3 does make lenses more approachable. I think that there's stuff in there that will. So in our book, what'll be interesting is, do we like default to turning on the new equality stuff in Scala 3? So Scala 3 has an optional feature, which I think we turned on. No, I don't know if we turned it on in our example code that we were working on, but so you know how in Java, you can compare any two objects, say, are these two things equal? And because there's a dot equals on object on the top level object, and this actually is a source of bugs, because there's oftentimes where you are comparing things that you shouldn't be comparing. Maybe you made a mistake and it's just a bug or whatever. But Scala 3 has this optional feature where it actually uses type classes to do equality. And so out of the box, there's probably a type class that allows you to compare an int and a string, for example. Maybe I can't remember, but let's say that type class didn't exist. If you try to go string, equals an int, then the compiler will say, hey, you can't compare these two things because I don't have any information about how they should be compared. And so this will be an interesting thing in our book, is like, okay, if we want to create reliable software, if that's our goal, then we probably need to turn on this new universal equality thing, because it's just a better way to be reliable. And then there's certainly some pain with that, because then you can't just say equals and have it magically work. So magically
work or not work sometimes.
Yeah.
No, there's a lot of blunders that, and it's confusing. I mean, there's a lot of explanation you have to do mostly because you've got the primitive types and you have, regular objects and
yeah. I mean, thankfully, case classes in Scala have the equals implemented for you. I think that's true in Kotlin data classes as well, right? Like,
yes,
the equals.
Oh yeah, that's it. And I mean, one of the things about records and case classes and data classes, and I forget what they call them in Python. I mean, that's why it's been this sort of sweeping change throughout at least some of the languages, is because all of those extra functions that you had to write by hand were just breeding grounds for errors.
Yeah.
And it's like, why didn't we do this before?
Yeah.
Yeah. And so it's so obvious. And also the more I think about it, the more I go, when you serialize and deserialize something, isn't it mostly like a data class or case class or what, one of these data transfer objects? We could generalize to that idea. And it's like, mostly it's not the whole object that you want to serialize and deserialize. It's just that data structure part.
Yeah.
And so, and I think I haven't delved into this, but what little I looked at for Kotlin was that's where its focus was. If you had a data class, it could automatically serialize and deserialize it, which is really mostly what you'd want, I would think. You don't want magical functionality coming along with your object, because we learned in Java that just threw open the door to
all sorts
bad
of
code
issues.
Yeah.
The GADTs again are, I think, gonna emerge with Scala 3 as being just so much better of a way to do all this.
One of the strong features,
I think with serialization and deserialization, one of the biggest challenges that you get into with it is that oftentimes the way that you want to represent your object in memory is not the way that it's represented in the serialization system, in the serialized form.
Sure.
And so then you've got this mismatch, and then you need to provide some way to configure it. And the way that type classes enable you to do that kind of overriding from the default is where you see, I think, a lot of the value there. And it's so the way that we do this a lot in the world of Java and Kotlin is with annotations. Right. And so then you have to go figure out what annotation do I need to use here to give some metadata to the thing that's doing the parsing. But then of course the thing that's doing the parsing has to, know how to deal with the weird thing that you're trying to do. So there has to be an annotation. And then if you're using annotations, most of the time those are going to actually run at runtime using reflections. So you've got all the pain with that. And then you can use capped, the annotation processor in Kotlin to do the annotations. That's what Kotlin X serialization actually does, is it's, I think it's using cap, but I'm not certain on that, to do that annotation processing at compile time, essentially like a macro. And it turns out that type classes are just so much better of a way to deal with this whole problem.
Well, and this is the first place I think I encountered the idea of versioning as a necessary part of your system, because they were way back when I was first figuring out how serialization and deserialization worked, which my first exposure was in early Java. And they're going, well, see, one of the problems is you might change your data structure. And so you have to have versions, and the thing has to read the version. Yeah. And it was all very hacky. It wasn't built in. And then years and years later, this idea that Unison starts to integrate, which is yeah, that's true with every piece of your code.
Yeah.
Anytime you change your code, it's a new version of the code. And pretending that it's still the old version is a super bad idea.
Yep.
And one of the reasons that we have so much security problems with our code.
Yeah.
And then you start thinking about it.
Well, and pain of upgrading, because...
Right?
Yeah.
Right? Because, how do you upgrade when things don't have reliable versioning on them? And it's, once you start thinking about it, you just go, oh, this whole thing is a nightmare.
Yeah.
And without having language support for it.
Yeah.
And so it's I wonder how it seems like there might be some way to backdoor something like that into Scala. I mean, it would probably require tooling and libraries and stuff to pull it off, but so that anytime you changed your Scala code, it would automatically create a new version number on it, so that your pieces would have to be put together.
Yeah,
use the old one, or if you're going to update.
That the tasty stuff is supposed to try to help with this, at least in some way. So that'll be interesting. I think that people are using evolvable serialization technologies like protobufs now as a way to isolate and deal with these issues as well.
Because with protobufs, if you change the data structure,
you can only append.
Right. Okay. So it prevents you from, and if you try not to do append, what happens? Does it say this is you have to name this something differently, or
technically, I mean, you could do whatever you want. You can screw it up. So I guess the pattern is that you number your protobuf fields and you only ever append to that list. You never go in and change an already defined. But it's kind of like it is up to you as the developer to have a practice around that. There's nothing actually that enforces it. Okay. It's just that if you don't do it this way, then you're going to run into runtime errors because
the runtime will actually report to you that this is not working, this is broken.
Yeah, I think in the case of Java, you'll get an exception if you try to deserialize something that is not in the correct protobuf form or whatever. So
okay. So maybe protobufs are at least taking a significant step towards.
Yeah, there is something really great in the idea of protobufs because it does isolate us from a lot of these issues, and maybe that's something we do in the book. But I'm not totally convinced on protobufs as the solution, primarily because
the solution for
serialization and deserialization mainly. As like the universal all figured out solution, because protobufs almost, I think universally, maybe there's exceptions to this, I think require like compiler plugins, not a compiler plugin, sorry, a build plugin to generate the code for you, the stub code for you from the protobuf definition.
Sure.
And that method of code generation to me has some issues with it, and so that's part of why I'm not totally convinced yet that.
But apparently, it's practical enough that Google uses it like all over the place.
Yeah, but there are some trade-offs to that. Like there, in the case of Google, they're using the monorepo and have all this tooling around the monorepo. And you know, there's probably a number of things that make it work well for Google that if you're using it outside of Google, you may not necessarily get. So as an example, one of the reasons why I don't like build plugins is that oftentimes the build plugins don't work. They're generating code that is then they're generating code before the compiler runs. And there are oftentimes issues with that process. One is like, how does incremental compilation work well with that? What if I like want to do something with a macro? Like, you know, there's CodeGen. There are some downsides to CodeGen. Another one is oftentimes the code that's being generated, I kind of care about it. Like I want it to maybe I want my API to be written in a certain way. Let's say like I don't want my generated code to use exceptions. I instead want it to use options and return options without exceptions when it tries to like deserialize something. Well, you can't. There's no hooks like to be able to do that. There's no, you can't go in and change how that code generator is actually writing the code for you.
Could you insert a layer in between you and the protobuf to, change the exceptions into?
I don't know. Maybe you could. I mean, yeah, you could probably have a code modifier. So you like do your code generator, you do your code generator modifier, but then it just starts to feel like xdoclet, and I don't ever want to go back to like what xdoclet was. Xdoclet was an annotation-based code generator for Java because writing
for documentation,
it wasn't annotation based. It was document. So in the document block is where you would put your xdoclet annotations, because I don't even know if Java's had actual annotations yet. But anyways, you would do them in documentation, and then xdoclet would run and pull out all the code comments, generate code, based on the information that was contained in the documentation.
Yeah, it must have been before annotations.
Must have been.
Yeah. Okay.
Anyways, it was, God, the things that I ran into in that world just to put a bad taste in my mouth for code generation in that way. I would so much rather use macros. Macros have their own pain because they're very much more black boxy. You can't just go in and see the code that was generated. Mm-hmm. But I would so much rather use macros for code generation, essentially.
Yeah, because at least you're working with something that has passed through the compiler first, or partway through the compiler, and you have a...
Yeah. So in the Scala 3 world, I've seen a few experiments specifically around protobufs, and type classes and GADTs. And so I think that'll be an interesting area of exploration, is like, can we use protobufs in Scala 3 and not use like build plugins and like, can it be nice enough where I won't be offended by it? Josh Surratt has been doing some exploratory work on that front. And then there's also a library called Scala PB, which I haven't looked at all, but I'd be interested to see how they do this, and how they will do it for Scala 3. And then there's also Zio gRPC, which I need to look into, which is the gRPC layer.
And who's writing that?
I don't know.
Oh, okay.
Somebody.
Is it somebody presumably in the Zio community, but at the company, maybe?
I don't think that.
Okay. Yeah, just company. But so there's some. So people are seeing possibilities for making
this all better,
a more pleasant process. Well, that's
so we'll
pretty
explore
attractive.
all this for our book, because I think that probably inter-system communication is probably something. Doing it reliably is something we'll have to cover.
I mean, if we can get there, that would certainly be pretty amazing kind of problems to solve. Especially because what is our model? It's what successful model do we have? It's the Swedish phone company.
Erlang.
Erlang and Elixir seem like they're the most successful big distributed system with lots of processes. And that's let it fall down and prop it back up.
Yeah, let it crash.
And then restart it. Which is a fascinating model, but seems like maybe we could do better.
Maybe we definitely can do better. And this is the actor model that I've used in Akka, and for distributed systems, it's certainly one model. And gRPC is another model, and Kafka is another model. And so there's building distributed systems. There's a whole lot of approaches, and I'm interested to see how in our book, how we want to, if that's a topic we want to tackle, and which way,
how far we can get, and whether that, if it's
Zio in particular has some great stuff just kind of built into Zio around this. Like we were talking about retries, just as an example of retries in your typical imperative system. It's painful to do retries. And so usually I just don't, or you can like punt to, now the meshes, the service meshes like Istio, or Envoy, they have the ability to do retries for you. So you kind of can externalize that concern, but I've never been real fond of like having that kind of logic external to my code. It just feels like something that actually should be a concern of my code, is like, how long do I want to retry for? What do I want to do if my retries, if I fail on my retries, that kind of stuff. So
that's what I
want it to be in my code. And so Zio has built into it very simple retries. You just do .retry, give it a number, and it'll retry. But then I think that the reason why Zio has been able to create a better programming model around this is because it's an effect system, and that is a much better foundation to do that kind of logic on,
because it maintains control of all the effects, rather than just, because if you think about the way exceptions were presented originally was that, oh, and one of the things that you could do is exceptions allow you to set up a retry. As long as you capture all of these things, then it's possible to go back and do a retry. But it's kind of a very low level way to do that, because you would have to then say, oh, what are all the things I need to hold on to here in order to achieve this retry when I get this exception. And then you have to have a whole bunch of clauses with your exceptions and then go back and do it. And then, boy, the chances of you getting it right would be maybe. Whereas if you could just say, okay, all I have to do, and it seems like, well, ultimately, how do you recover from an exception? I mean, an exception is either a programming error, or it's something, typically IO. You try something, doesn't work, you don't know why. Your only choice is to say, oh, well, I'll retry.
Right.
And so if that is your one choice, then, boy, making that simple would make it possible.
Yeah.
Whereas I feel like exceptions, well, if the programmer is expert enough,
right,
they could put together a retry, but that's going to take a lot of work.
Yeah. So we just don't.
Mm-hmm. Yeah. So typically we don't.
Yeah.
It's funny because there are these things I keep noticing. It's like, if this development system makes it easy enough, you go, oh, sure, I'll do that. But it can just be a hair that makes it a little too hard, and so you don't do it.
Yeah.
You don't include it.
Yeah.
So that could be pretty revolutionary.
Yeah.
To be able to retry easily.
Yeah, and this is just one example of kind of recoverability or attaching alternate flow logic to effects is so much easier than when you try to do this with a non-effect system. Because with effects, you're not actually, when you define your effect, it's not actually doing anything. It has to be run, it has to be interpreted. So really all that you're doing is building up this like graph of things that should happen. And then the runner is what's actually talking to the outside world. So I think the effects end up being a lot better foundation to build on for attaching alternate flows to your main flows.
So I had a little insight during the week because, you and Bill have been throwing around the term effects. I'm going, what does that mean? And then I was thinking about, what a pure function is. And I go, it has no side effects. And then I go, side effects. Oh, things that change that are kind of outside of the main goal of your function. Or, a side effect could be part of, like when you do print line,
that's a side effect.
That's a side effect. It's like, oh, you're modifying the console. So it could be the goal of that function. In fact, if you have a statement rather than an expression, well, the statement relies on having an effect happen rather than the return value.
Yeah.
Which, when you think about it now is, oh, this is frustrating. Why do I want to do that? Yeah. And it's like with a lot of languages, the idea of an effect is just, oh, sure, that's just the way it worked. And then when you start really thinking about it and the problems that come from having an effect from your calling this piece of code rather than producing a result, then you start going, oh man, it's all woven into these languages.
Yeah.
And then it begins. So now it's starting to click. I go, oh, that's the effect you're talking about. It's what we used to call side effects, but it means any change in your environment
any talking to the outside world.
that isn't producing a result from your expression.
Yeah.
So.
Yeah. And it's even simple. So println is a good example of an effect that's talking to the outside world. Random number, that's an effect. Asking a clock for what time it is, that's an effect. All that stuff is talking to the outside world.
And you don't know, I mean, you can't say, oh, I know what I'm going to get from this. I know what's going to happen. Whereas with a pure function, it's like, yeah, we put these values in, we're always going to get those values out totally. Yep. And once we get that
testability becomes so much easier because when you're running your tests, you give it a random number generator that's deterministic.
Mm-hmm. Which is what I've always done in my book examples is I've seeded the random number generator with something. So I always get the same results. And I didn't know that I was like controlling the effect.
Controlling the effect.
Yeah. So it's starting to come together.
Making the effect unaffectful.
Mm-hmm. Mm-hmm.
Yeah. Yeah, so it's going to be super fun in our book to explore all this and try to teach effects in a way that is useful and about the why, about the problem that people are trying to solve.
Everything start with
not
why.
Just because there is a mathematical foundation to this, which is great to have, but not necessarily useful when you're trying to teach somebody. It's nice that when you have an effect system, most of your code is pure functions. That's really nice. And there is a wonderful mathematical
and then when you start assembling these pure functions, the resulting function has the same reliability as the pure functions.
Yeah, exactly.
And you're able to control that. Yeah.
But that's not necessarily the why. It doesn't relate to what benefit
the why isn't the math that proves it.
That's right. Well, the same thing is true for monads.
Absolutely.
There's the wonderful mathematical model underneath monads, which make them amazing and useful.
A monad is a monoid in the category of endofunctors.
Yeah, I still have no idea what that actually means.
Those are just noises I'm making with my mouth.
Yeah.
Yes.
So it is wonderful that there are these mathematical algebraic laws underneath this stuff that allow us to have expectations about how it's going to work.
But I'm totally happy to say math backs us up on this.
Yeah.
Period.
Yeah, that's right.
If you want to learn about the math, I don't know. You'll have to research it yourself.
In our book, we will not go into the math.
No, because it doesn't help. What helps is to understand why we're doing this. In fact, there's this author, Simon Sinek, and he has a book called Start With Why.
Yeah.
And I found that to be, because it's actually talking about you personally. It's like, why do you do the things you do? And it takes a while to figure out why you do the things you do. But once you understand that, you can look at all of these problems and go, does this fit with my why? And if it doesn't, I should figure out how not to do that.
Yeah.
Because that's not going to motivate me in the long term.
Yeah.
Yeah. So we're going to try and do that.
We're going to try and do that. That's going to be fun. Yeah. What I do wonder is with Scala 3 and with Zio, I think, is there an opportunity for Scala to kind of get back into the spotlight, gain some momentum on the adoption front? Not that I really care, but because I like Scala and I'm going to use it. But Scala has definitely waned in terms of its the energy kind of around it, the interest in it. And I think Zio and Scala 3 have an opportunity to bring some of that back. But I do think that it will take the starting with why, because
they didn't do that with Scala 2. And we had things like Scala Z, which we now realize was trying to make Scala be Haskell. And if you simply knew that going in, that would have changed your experience. Yeah. But whenever I tried to look at it, watch videos on it or anything, it was just like, no, I couldn't. Yeah. I didn't understand what was going on with it or why I should try and understand this thing at all.
Yeah.
So if we can present it that way, I think it's possible, especially because, look at Python. Nobody in the Python community was worried about adoption. They were going, we're making this language because we like it. If you don't like it, use the language you like. We're not trying to evangelize this to you. But there were other values in the Python community. Like a big one was to be a friendly community, nice to everybody, never denigrate somebody for not understanding something, on and on. And the whole structure of the community was built on that principle.
Yeah.
And I think that was not a concern, let's say, for Scala 2.
Right.
And also, I think there was not a concern I think there was this interest in experimentation that Martin had, which is great, as long as all you care about is experimenting. And I feel like Scala 3 has done a lot of things, at least in our initial skim over it. I keep seeing things, I go, that seems friendlier to me. That seems more accessible. And I think the community needs to, I don't know how long ago Bill Venners called me and he said, so how did Python, get create this friendly community? And I said, well, basically from scratch, from day one. This was something that was important to Guido, and like a fundamental principle or foundational part of the language was, and you see it reflected in the language itself. Make it easy and accessible. And so I think there needs to be some work done, because if you walk into, I had a number of experiences where I'd go into some kind of chat room or news group and just get flamed. And it didn't bother me because I've had enough experience struggling with things that I know. I don't know. You're lots of things.
Putting that asbestos suit on, and
it wasn't not even that. It's just like, I don't know things. So telling me that I don't know things isn't going to bother me.
Right.
That's why I'm here. But if you're going to be mean, then I'm going to go someplace else.
Yeah.
And I think, I don't know how much of that is still in the community, but
I think most of it's been rooted out.
Hope so.
And then if you're in sub communities like Zio, I found Zio to be much more friendly and inviting and helping of beginners. And,
Well, we're probably going to spend some time in those communities as we try and make sense of all this stuff.
Yeah.
So, but I would say those things are but also I really feel like the fact that Python never cared about how popular it was or how much, that wasn't its focus. Its focus was on making the experience great. And now it's, competing with Java for number one slot, which nobody ever expected that. That was just, that wasn't the goal. That wasn't the care.
Yeah.
And there was no marketing department for Python like there was for Java. Was it the language or was it the marketing?
Yeah.
You always have to wonder that.
Yeah.
And
it was the enterprise sales team for sure.
Oh my gosh. And that was think about the billions of dollars that were lost because somebody hacked together enterprise Java beans and pushed it on everybody. And they go, well, Sun obviously engineered the heck out of this thing, so it must be good. Let's use it. Why isn't it working for us? Why? Oh my gosh, what a mess that was. I feel like if we could keep marketing out of languages altogether and just let everything stand on its own merit.
Yeah.
That would be a step in the right direction.
That sounds good. All right. Well, Scala 3, Zio 2, reliable software. Here we go.
We'll see what happens.
And we'll keep our listeners apprised of the developments.
Of whatever stories we currently have in our heads.
Yeah. All right. Well, thanks.
Thank you.